Here's a recap of the derivation we had for the law of cosines. We discovered this as just a distillation of a very practical method of solving an SAS problem. And I just wanted to run through somewhat quickly, but focus on a couple of the subtle issues that I really don't think are terribly important, but that they do come up. So the one case that we were looking at the start was like this. Let's say, and sometimes I get the side letters mixed up, but let me be careful about that. Okay, so let's say we label the sides like this. The labeling doesn't really matter, but once we label it, we got to stick with it. We were given a, little b, and big C, the angle here, and we want to find little c. And everybody focuses on, naturally, on finding this altitude. Let's call that h, because it's like the height of the triangle. And then people pretty quickly realize that if you can find this, let's call that x, and then you can find y, because it's going to be a minus x. Okay, so y is just this part, and x is just this part. Okay, so we get that h is b cosine c, and that x is b. Ooh, just kidding. La la la. That's sine, because it's opposite. And x is b cosine c. Okay. So, and then y is going to be a minus b cosine c, because in this case, x plus y equals a, or y is a minus x, just by the distance along the line here. Okay. Notice that that's actually the kind of algebra that goes into what happens if you have a boat problem and the boats are either going kind of toward or opposite each other along a line. So that's kind of coming in there. The other thing that came into special cases of the boat problem was Pythagoras, and that's what we used to finish off the problem. Once we know h and y, we know that c squared is h squared plus y squared. And so that's going to be b sine c all squared plus a minus b cosine c all squared. Okay. So again, this might look a little different from what we were doing in class, because the letters might be different just depending on which one is a and which one is b. So, but let's do it this way. Okay. So that's actually a pretty good formula. If you just take the square root of this thing, you've got a formula in terms of a, b, and big C for little c, the side. It's just not as pretty a formula as it could be, that's all. So this is one of the things that we did all together. Or at least some years I do it all together. And I'm just squaring out that second piece. Okay. So, and then I'm running out of room. Okay. So, what can we do with that? The nice thing is that I can do one of two things. I can either take this sine squared and I can use the basic Pythagoras identity to turn that into cosine squared, or once I've written this out, oh look, this is a common factor of b squared, and what is it multiplying? Sine squared plus cosine squared. Oh, that's really nice. So let me just, I want to keep the picture. So let me just rewrite. So c squared is going to be b squared times the quantity sine squared c plus cosine squared c. And that should hopefully look familiar. Plus a squared minus 2ab cosine c. If you rewind a little bit, that's exactly just collecting everything. And that whole thing is 1. And so you actually get a squared plus b squared minus 2ab cosine c. So mainly it's just a little bit of algebraic cleanup, but any kind of algebra involving trig functions almost always, well, at some point you use a trig identity, and that's the granddaddy of all trig identities, the basic Pythagorean identity. And it's actually nice because we're using it algebraically, but what was the key to this? It was all about Pythagoras. We used Pythagoras geometrically, and now we're using it one more time in terms of more algebraic formulation. So there's the law of cosines. Now, that was one of the issues. Just how does this algebra come out of the geometry that we did with doing the perpendicular and everything? Well, what if C was an obtuse angle? It seems like we're really using the fact that this perpendicular ends up in here. especially when we use this fact that x plus y was equal to a. That seems to make it really important that this division point is inside that interval. Okay. So this was the other issue that I had to go, well, at least in some years I have to go through pretty quickly. What if it's an obtuse triangle? Here's A again, here's B, here's angle C, and here's little c over here. So you can still drop a perpendicular. You can still drop that altitude. And we can still call this x because it's associated with, let me make sure we know that that's B. We still call that h. And we can call this y. And we still have a little right triangle that's just HB and x. We have a bigger right triangle now, which is HC and y. We still can use Pythagoras and sines and cosines and everything. But here's the only differences. Okay? It looks like we shouldn't use big C to analyze this triangle, because it doesn't seem to make sense to say x over b. That's not equal to cosine C, right? Well, that's